All right. So, whoops, something weird has happened. That's all right. Let's go here. There we go. All right. So there's a list of languages on GitHub, and this is apparently it. And I wonder if I can make it bigger. Yeah, so JavaScript is #1, then Python and Java and PHP and C and Ruby. I don't know what happened to Go. Anyway, but the hottest one growing most rapidly is Dart, whatever Dart is. So anyway, I just learned Go, and I feel sort of offended that it's not even in the top 10, but whatever. There's a lot of languages, so I guess the new hotness is Dart, but JavaScript and Python and PHP are still big, and that makes sense. Anyway, that's somewhat interesting. Of course, once you know one, it's pretty easy to switch to another one, but anyway. All right, this one got my attention. All this person did, they were at work, and they thought somebody had put spyware on their work computer to monitor what they're doing, which certainly happens. And so they hired a consultant, a couple of consultants, to analyze their computer to see if it was being spied on. And the consultants put Wireshark on the computer to sniff the network traffic, and now they're being prosecuted on the grounds that that is illegal hacking. And if that's illegal hacking, I think we're all in trouble. I mean, if you can't examine the networks coming into your own machine on your own wire, then what's going on here? Anyway, one of the consultants was a previously convicted child molester, and somehow that's making it more of a legal problem, which I wouldn't think so if you've already done your time. But anyway, the part that got my attention is if you can't even run Wireshark, if that's an invasion of somebody else's privacy, then what are you supposed to do? Anyway, hopefully that will go away. But there may be more to it, but the technical side of this is very strange sounding. And this one is pretty awesome. If you know quantum mechanics, which, you know, I talk about quantum encryption and I come across physicists, the point of Schrodinger's cat is if you have an atom can easily be in a superposition state where it's half one way and half the other way, and it's not determined. Like it might be spin up or spin down, or it might be going this way or going that way. And you can make an atom and then have it detected by a detector, and then have the detector release some poison. So that means there's a cat that's superimposed in a state partially alive and partially dead, because there's a 50% chance that it has released the poison and it hasn't. And until you measure it, it remains in an unstable state, supposedly. This is what one interpretation of quantum mechanics. Anyway, what these guys did is they did a theoretical study, and they actually figured out that there are two, see, this is the collapse of the wave function. It's one of the big mysteries in quantum mechanics. When you observe something, it stops being uncertain and becomes certain. And nobody really understands how that works or why that happens. It does really happen, though. And they figured out that when you observe it is when you like send light into it to see what happens, but that's not what causes the collapse. What causes the collapse is when you take the light coming back and measure it. And they figured out you can do two measurements. One is to measure whether it's collapsed or not, and the other is to measure which state it collapsed into. You can only measure one of those two things. And if you don't measure which state it collapsed into, but you just measure that it did collapse, then you do not cause irreversible determination. You can run it backwards. There was a real experiment doing time reversal in quantum mechanics about 6 months ago, where they had atoms achieve a state and then they moved like the electric field to push them back where they are. You can run time backwards to some extent in quantum mechanics. And you can measure something about the cat's condition and then decide to roll it back and make it uncertain again. So that's pretty exciting. And this is the kind of fundamental stuff that right now has no application at all, but it might have consequences for quantum computing, quantum teleportation, and all these things. If you're actually going to understand what's going on with this collapse of the wave function, it's more than 100 years we've been trying to figure out what that is. And this is a major step forward in understanding it, that it's actually two things mixed together. So it's interesting and very deep and no immediate application. And on the other side, Trump has a spiritual advisor, which is news to me. She's one of these prosperity Christians. It says, God will make you rich. There's always a bunch of them. And now she says the reason why people don't like Trump is because they are sorcerers and witches. So, well, that's one way. I grew up. This was really common in Pennsylvania where I grew up. I think it's been a while since we've had this on the national stage, you know, burn the never Trumpers at the stake to cast the demons out. She lists the demons by name that are causing the Democrats to have candidates and stuff. So there she is. So there you go. This is Trump going where Republicans used to go. I didn't know Republicans still went there, but he's making Republicans great again by making them back into the demon people. Anyway,
Harry Potter, me too.
What's that?
We all love Harry Potter, me too.
That's true, Harry. There you go, Harry Potter. Yeah, God can make me rich. Oh yeah, absolutely. This is the one that's been around forever. This goes all the way back to every religion. There were some there were some heresies in ancient Judaism and stuff. This is a very popular idea in religion. That, I mean, it makes sense, right? If you were a moral person, God would bless you by making you rich. Why would you be miserable and suffering? This is why, a lot of people have problems with Christianity. What, you mean this is the guy that's the best guy and he gets tortured and dies? What kind of religion is this? The good guy should win. I mean, anyway. So they have a report on bridging the skills gap, the interesting, they have 2.8 million people in cybersecurity, but they need another 4 million worldwide. So I hear these numbers fly around, and it's certainly true. They need a lot more people. Anyway, there's a thing, Security Onion. I used to teach in this class, and I gave it up because it really didn't work at all. But the Security Onion is still developed. They have a con, and the developers are super proud of it. They say, now it's as good as a commercial system. It's really awesome. You should try it again. And I'm not convinced. But if any of you are motivated, you could download Security Onion and try it. It's supposedly the free product that will totally replace Splunk and other tools with open source tools. And I used a textbook about it, and my students spent the whole semester installing it and trying to make it work, and we all just cried and were miserable. It totally didn't work. I hope they've done a lot of updates. Of course, I said the same thing about Cyber Patriot 10 years ago. I said, this is totally lame and I won't do it. And now it's much better. So there may come a time when it actually gets good and it's worth using again. So China has a curfew for video gaming. So minors can't play video games anymore more than an hour and a half in the weekdays and 3 hours on the holidays, and not at late at night to like save them from themselves. So, and they now made a quantum computer from photons, which is certainly what I expected. The actual thing you use to make the qubits is hard to make and hard to keep cold, and it would seem like using light for that would be the best solution. So they're now getting there. All the ones now require superconducting magnets cooled down to an incredibly cold temperature, like 1,000th of a degree from absolute zero, and that is really expensive. Using the light would seem to be a much better way to have a pure quantum mechanical object that could be at a reasonable temperature. Anyway, now Caitlin's gone because I should mention on Halloween was last week, and we went over to the engineering lab where they have a sort of party on Thursday nights with coffee and stuff, and we blew smoke rings and stuff, and now they're building sumo robots. They're having a sumo robot competition, and there are going to be prizes next week or week after. You can win. You make a robot. They have robot kits. You program the robot, and then the robots go into a circle. They push each other out of the circle, and if you win, you win $100 and eternal glory. So she's over there building a robot. So if you want to do that, after this class, we can go over and see how they're doing, and people might want to come on Thursday night if they want to build robots with the engineers, because this guy's great. He's like the stuff we do over here with our team. He has engineering teams, and City College is now the uncontested champion, I think 2 or 3 years running, at building solar-powered boats. They make the best boats. They win the races. They take them out to like a lake around here, and all the colleges and high schools or something compete, and City College is the winner, and he runs that team. So the engineers have a team, sort of like our cybersecurity team, doing good stuff. And I think we should work together more. Anyway, so let me bring up the official topic, which is Windows forensics. And here we are. There's 3 lectures about this. This is a big stuff. This is a large part of a computer forensics class, and I always more the same. Remember, we talked casually about how you would take a disk image or a memory image from a machine if you really want to analyze that machine and find out what's been going on. And this is the start of it. You really learn a lot of Windows internals. And I also mentioned that if you do the Splunk project, what you're really learning is not so much Splunk as Windows. You're learning how to read Windows event logs and all the other logs. That's the part that's hard, is learning how to read Windows event logs, really. Here's what we're going to do: the structure of the Windows file system, NTFS, prefetch, and event logs, and scheduled tasks. And then a whole chapter on just the registry. The registry is huge, and there's tons of interesting stuff in there. And then a 3rd chapter on more stuff about it. And this is all Windows internals. And if you've taken a Windows desktop support class or certification in Windows desktop support, it helps a lot. Because understanding how Windows works is essential in the modern world, because 90% of people still use Windows on their desktops, and corporations totally use it because of domain controllers. And that's why I gave you this project where you have to build a domain and then put on a real professional tool. And by the way, I should also mention, because if students have not done Windows servers at the technical level, they are going to feel very frustrated. Windows servers are monstrously complicated. There are like 4 or 6 classes and certifications required to understand them. It is not something you can just figure out very fast at all, not like Windows desktops at all. And so anyway, the projects here, I made 3 projects together that you can be doing, making your domain controller member server, and then putting on this eventing endpoint manager, which is really, really frustrating to put on. Enterprise class software is very broken, very buggy, full of weird error messages, full of weird problems. You have to keep stopping and Googling how to overcome problems. It's not going to be much fun to do this, but it's very good for you to get used to the world of enterprise class software. But if you don't want to do all of that, as mentioned, you might want to do Go. This is Go the wrong way. So feel free, there's like 300 points worth of stuff here. You can learn to do simple things in Go. And I'm going to be teaching this to everybody. Let me teach it for a while. But this is a lot more fun and a lot simpler. And that's another direction to go if you want to. Anyway, that's worth free extra credit in any of my classes. So check it out if you like. It's just at the top of my homepage, Go the wrong way. And I'm hoping some people will do it just so I can get the bugs out of it before I go to conventions and stuff. But anyway, it's an option if you need to do more project or extra credit. Although in this class, you probably should be doing the Splunk projects. That would probably be most directly related to incident response. And that's another ton of extra credit that you can get. And learning how to use Splunk, you will not be sorry. Anyway, so here we are in some Windows artifacts. So the Windows operating system is all around an NTFS. This is their new technology file system they brought out in 1993. And it has never been updated in a major way since then, just small implements. Many times Microsoft has promised to make a new file system to replace it, and every time they have given up and not done it. So the only thing they did is they made a REFS, resilient file system, which is supposed to replace RAID arrays on enterprise class servers. But all normal Windows installations that run on just one machine use NTFS. And now the old system was FAT, which came from floppy disks, and it was very primitive, and it didn't even have a access control list for the files. You couldn't even say administrator gets full control and users can only read and things like that. And that was really pathetic. Just physical access to the disk meant you could do everything with it. That was the old days. And that was, of course, way too primitive. So they moved to NTFS. Now, NTFS uses a master file table, which is a database at the start of the disk, and there's a backup copy on the disk. And this is where it stores a database of records, which is where every file is, how big it is, the access control list, the creation date, and all this metadata about the file. That's how it works. So the master file table is where you find timestamps, size, attributes like permissions, the directory structure, and the contents of files. Small files are stored entirely in the master file table. Larger files, files bigger than about 1,000 bytes, are spread out in clusters, but the master file table points to the clusters. So each NTFS volume has its own master file table. Normally you just have one disk called C, but you can partition your disk and have C, D, and E and stuff, and then each one of those would have its own master file table. And it's stored as a file called $MFT. You can't find it by just opening my computer and browsing. You have to have access to raw disk to find it. And so it's on a standard drive. It's a series of 1024 byte records, one for each file and directory at a volume. And so there's $MFT and $log file and more. So you can open WinHex is one of the tools that lets you do this. WinHex is, I think, one from X-Ray Forensic that lets you do this. And you can see the root volume here. And here's a couple of files, file 1 and file 2. Those are normal notepad files. But all these things starting with dollars are these metadata files that are used for the organization of the disk itself. And here's the master file table, and here's the mirror. There's a second copy of it kept because it's not very big, and it's super important to not have it get corrupted. If the master file table gets corrupted, you've lost access to all those files. That's not fun. So each entry has got a record, and if you have done Linux Inodes, it's the same thing. This is just Microsoft's version of the same thing. You have to have a directory someplace that stores the metadata about each file. And the point is, when you delete a file, all it does is remove the master file table entry. It does not go erase the data. So the data is still there, but the file name is gone, and the owner and the timestamp is gone, that sort of thing. But you can totally reconstruct the contents of the file, even though it's gone. And so, what's that?
The mirror of MTF is much smaller than the MTF.
Well, I think it's the same size. The MFT mirror is, oh, it is a lot smaller. You're right. Huh? I thought it would be the same, but I don't understand that. It's a good question. I thought it'd be the same, but it's not the same. And I don't know how that's possible. Maybe the mirrors. I know there is a backup somewhere, maybe there's another backup somewhere that's not in this list. That's a good question. I don't know the answer. Anyway, so there are attributes here. Standard, so many bytes for the file name and so many bytes for the data and so on. The standard information. So like I say, delete a file that marks its master file table record inactive. Nothing else has changed, which means you can even recover the metadata until it's used. But in principle, if you just delete a file and 5 minutes later you want it back, you can actually get the whole thing back, including the metadata. But if you create another file, it will always reuse the MFT entry, and that will destroy the metadata. Another thing to mention, by the way, is if you're using SSDs, which many people are, SSDs, the data does evaporate most of the time when it's not in use. A few seconds after you delete it, a garbage collection process cleans it up. So recovering deleted data on SSDs is not likely to work. It's only going to work if your SSD has a driver from an old version of Windows or something that does not implement the full features of garbage collection, which is what makes it more efficient, supposedly. Although I found doing tests on the Mac and of course their SSD that turning off garbage collection did not create any significant performance difference. But the idea is that that garbage collection is there to make it read and write faster. So there's 4 timestamps: modified, access, created, and entry modified. Entry modified means I think that you changed the metadata. And it's always got a standard information and the file name, 2 sets of attributes containing MACE file stamps. So there's a lot of time stamps on a file. And if you go into the properties, you'll see a created date here. And these are standard information timestamps: created, accessed, and modified. The entry modified timestamp is not available in Windows Explorer, and you can see it with a forensic tool like FTK or Encase. Also, there are some weird situations under which these things are not all updated correctly in versions of Windows, so you have to be careful when interpreting them. So modified is when the contents were changed. This is when it was last read. Created is when it was first created. And entry modified is when the MFT was changed, something like changing the file name. Here's a fun demonstration. I don't think I'll bother putting it up to show you. If I do a Windows file and calculate the MD5 hash, and then I change the file name and calculate the MD5 hash again, what's going to happen? Any guesses?
Same.
It's the same, because the MD5 hash does the contents of the file, not the name. Doesn't include the metadata like the creation date or anything. Of course, that it would not. It's just the contents. So if you were to change the name of the file, that would be this entry modified. Nothing else would have changed. Anyway, and that's what I remember. The access timestamp is no longer updated, though. So that 4th one that's hard to find is probably not worth much of anything anymore. Even if you enable it, it might be out of date by an hour. So I think Microsoft found that that 4th timestamp was not worth the bother. So probably it's useless these days, although what you really have to do in forensic investigations is you have to do tests on a test system to find out what happens. Because the fundamental concept of computer forensics is this: Microsoft, you can buy spyware products that spy on people, like, for example, this LAN desk. It's totally there to record what everybody's doing. But if you don't do that, none of this is intentional. Microsoft is not trying to spy on people. They're just trying to make the machine work. And that causes them to collect a bunch of data accidentally. So forensic science is finding the artifacts that Windows leaves behind, but they are not deliberately put there, and they're not maintained by Microsoft. So you have to keep doing tests, because as Microsoft changes versions, the artifacts change. Anyway, so there's another set of timestamps here referring to the file name for itself. And another thing to be aware of is the MS-DOS 8.3 file name. In the original MS-DOS, file names could only be 8 characters, and you'd have a dot and 3 more characters, and many parts of Windows still work by that name. There are some command line commands that have unexpected results because the real file name is really still 8.3 letters. The longer name is kind of a decoration that is not fully implemented by all the commands. Anyway, so time stomping is the old technique of getting rid of timestamps. If you are any kind of hacker and you hack into a system, then one thing you want to do all the time measurements. And let me turn off the sound, because mute all does not work correctly in Zoom. And let's see, there's chat coming in. Robot building next Thursday. Yes, yes. So come here next Thursday if you want to do robot building. Anyway, all right. So there's a thing called time stomping, which will change all the timestamps to try to hide your tracks. And that's the game. There are even programs that can change all the timestamps, including that E one. That's hard to get to. And there are time stoppers that are included in malware to try to change all the times to make it look like nothing happened. All right. SI timestamps are easily altered. The FN timestamps are difficult to alter. So one sign of a malware or other attack is when these timestamps become inconsistent. That means one of them is modified and the other hasn't. So here you see an example. This is correct. The create modified is there, but here's the stomped moved back to 2006. So they stomped and moved all these things back. Anyway, and in the stomped case, they changed the created date, but they haven't changed these other things. Anyway.
Is there also a way to change your computer ID?
Way to change what?
Computer ID into like your laptop or desktop.
Your ID? Numbers. What ID?
No, I just no, basically, you know, the spam on, for example, a Mac computer, is the ID number on it?
What ID
serial
number? The serial number?
No, it's the, you know, like when you operate your Mac desktop and they have a serial ID. Can you like cloak that?
You mean on the hardware? Well, I mean, actually, this is actually a huge issue. There is no unique identifier on computers. There is on cell phones. There's the IMEI, but there's no unique identifier on computers. This is the whole point of digital rights management. If I download to my computer, there is no number that can be gotten from my computer that uniquely identifies it, and that is by design. The privacy advocates are big on this. That's why the lawsuits for people that steal music try to use your IP address or something, and it doesn't really prove who you are. Putin wanted to put this in, and the recording industry wanted to put it in, and Intel talked about it for years, that they would put some unique identifier in every computer, and then you could have things like software licensing, like when Microsoft wanted to put software license on Windows XP, there was no number to tie it to, so they took the MAC address of your NIC and the serial number of your processor and other numbers and mixed them together. But they were not really unique. This is actually a fundamental big issue. Putin wanted to do this. He wanted to make it so everybody on the internet has to tell you who they are with everything they do. So the MAC address is not only not unique, but it's also completely spoofable. Which all network traffic actually uses a software copy of the MAC address, and you can change it. And a lot of NICs are manufactured with identical MAC addresses, sometimes whole lines. And you can have an identical MAC address as long as they're not in the same network segment. So the MAC address is, in practice, generally unchanging, but it's not a unique stamp. There is nothing unique about your machine that can be measured from the outside that you can really count on. It's all alterable in software.
Yes, I noticed that sometimes like when they come to take your computers, something like that.
Yeah.
What are they looking for? A number of computers or serial numbers?
Well, people like to take a serial number, which is just like a sticker on the machine, just so they can tell who it belongs to, and they'll record that. But that, of course, is like your VIN on your car. It's just physically there, and you could file it off.
And also, basically, you know, all my computers, each of them has different numbers on it. I noticed that when I go to the operation windows,
yeah, they have some numbers, but those are not really unique, as far as I know, and they're not unalterable. This is a really important question because a lot of people would like unique identifier on machine, and as far as I know, there's none yet. The MAC address here, we talked about this. No, people talk, there was a version of IP version 6 in the early days that was going to put your MAC in the IP address, and everybody freaked out and didn't use that and used the random one instead. There was a very early proposal for IP version 6 that would cause your MAC address to be leaked out, and all the privacy people freaked out for this reason. Although that MAC address was also from software and could have been modified, and that's basically what they did. Now every machine, and by the way, even Macs and all 400 versions of Windows, in fact, randomize their MAC address now. They don't use the real MAC address. Every time you reboot them, they randomize it because the privacy people got very concerned.
How did they know it's you?
They don't know it's you. That's the point. Your router doesn't know who you are. The switches don't know who you are. If you take out your laptop and put in another one, they have no idea. Nobody knows who you are until you do something like log in with a password. And this is by design. This is why Google, that wants to track everybody, has a whole bunch of data. They have some data after you log in. They have other data from cookies they put on your machine, and they also keep track of your IP address. So even if you use another browser, they still know some information about you. And now everybody's tracking you and everybody's selling your data. There's a lot of money in it. So this is actually a big, big issue, and there's a huge battle going back and forth on how much data people have and what they can do with it.
Also, what if there's something like this? How do they know what movie I'm watching? I downloaded a movie from, like a website, and then my Comcast is telling me I downloaded this movie illegally.
Yes. The reason they know what movie you're downloading is if you use BitTorrent, you're actually downloading from many sources, and the Recording Industry Association of America puts up sources. They put up copies of the movie for you to steal so they can catch you stealing it. They pay a third party for that. So something like 5% of all the BitTorrent end nodes are the Recording Industry Association. They're like spies. And so there are special BitTorrent blacklists you can get where you'll only connect to the ones that are not the RIA, supposedly. But basically, they entrap you by putting up a copy that they're watching to see if you'll steal it.
But it's not protected, they just randomly put you on like pirate.
Yes, no, they hire a company, I forget, Media Century, I think is the company, and this is what they do. They put up servers, mix them in with all the others, and they put logging on them. They track down who's downloading it. So if you just download with normal BitTorrent, it connects to like whoever's the fastest, and some of them are the spies that will report you. So it's the same thing. I always wondered this about drug dealers. They start selling drugs to people. After a while, they have a lot of customers. Pretty soon, some of those customers are informants. If you have enough business, then you're selling to informants. And it's the same issue, you know. If you kept it quiet, like just a few people that trusted you. Like I knew a guy that had a club of just like 10 of his friends, and they would share movies and music. And that was it, just privately among them. And that way you won't get caught. But you don't, that means you have to pay like 1/10 at a time. So it's the same thing. Anyway, so SANS has a whole spreadsheet here. You can get a whole list of all these artifacts, and we'll talk about some of them, like user assists and last visited, most recently used, and shell bags. These are all the things Microsoft Windows creates on the machine to keep track of what you're doing, not for forensic analysts, but to make it more convenient. Like if you open a window and you shrink it down to like 1/4 of the screen, the next time you open that window, it remembers how big it should be and where it is. It remembers the location of every window you've resized. It remembers when you're looking at details view or large icons view. That's what shell bags are. And that means, coincidentally, it has recorded the time and the name of the person that was logged in every time a window was last resized. So I know what windows you've been opening and what you've been doing coincidentally. And that's what this all is. It's all there to make Windows run faster and be more personalized, but it means there's a record of everything you do. And that's very much like the internet now. And I heard the people that give you tests to go to college, the SAT, it just came out, the SAT is selling that data for money, and they're getting 51 cents per record of everybody that takes the SAT. They are selling it to colleges, and colleges are looking at that to decide whether to take you. Not even the score of the SAT, they're buying mass records of who's taking it. And almost everybody is selling this data. Someone else, I think the DMV is totally selling that data. You know, everybody you deal with is now harvesting your data and selling it and making big money from it. So it's
I also noticed that some of those, like these information that tell you who you are, like they look for you, intelligence something, and other websites.
Yeah.
They have information that my email that I basically send them to a job interview.
Yeah.
I put some crappy email account numbers and they still get it.
Yes.
So the people who put a fake job is selling my information, right?
Yes. Everybody's harvesting it, and it is pretty hard to tell who's taking it, where it's going. But this is why GDPR passed in Europe and California's passed a version. A bunch of people are saying you should be informing the customer when you're taking their data and informing them where you're selling it, and you shouldn't be allowed to do that without them agreeing to it. That's going to greatly change the way data is handled. But of course, in addition to selling it to everybody, they're of course losing it and getting hacked all the time. That's why one of the most crazy things you can possibly do is get a DNA test. Are you out of your mind? All the privacy activists freaked out decades ago about this, and now they know they were right. If you take a DNA test and give it to some cloud service, you made a permanent record of your most personal data you can ever erase, and you've messed up your whole family for generations. Because everybody has the same DNA in your family, very closely related. So now if they decide to hunt down some group of people they don't like, you've made it easier for them to find you, and you can't take it back. And now there was a big lawsuit this week where a judge ruled that private DNA databases are required to hand it over to the police in response to court orders. And not only the affected individual, they're required to just hand out vast amounts of data so they can search through it and hunt for criminals. Because they caught the Hillside Strangler like 20 years later by finding the DNA in its public databases. So the cops want to close cold cases by searching through those online DNA databases. And all the privacy advocates have always said, don't let some cloud provider scan your DNA. You'll be sorry. And that's all coming true. Yeah.
How about US sensors? Do they sell your information?
US sensors?
Yes.
Never heard of it. Who is it?
Sensors.
It's what?
Census.
Something about a dentist?
The census.
Oh, the census. Oh, the census. Oh, the U.S. Census. Well, I don't know. That's a very good question. I would hope they're not selling that data, but
They do.
but they're probably getting it stolen through not having it secured. But I know the DMV is now selling it, and I know the police are taking DNA from everyone they arrest, even if they don't charge them with anything, and putting it in a permanent record. So, and I know they're collecting all these license plate scanners. Those are donated. What happens if a company will come to the police, they say, we will install license plate scanners in your town for free. And as long as we get the data, you can get the data, you can track down all the crooks, and we'll also get a copy of the data, but don't worry about what we're doing with it. And the cops think it's a great deal. And so in a lot of cases, the government collection of data is in fact going to third parties without the government exactly knowing it or controlling it.
But I noticed that the email I first used, I get the US Census, which is in the one that they.
Well, I don't know. I haven't heard of the census data being sold, but pretty much everything is being sold, and we don't know about hardly any of it. It certainly is worth a lot of money. And so probably someone at the census is stealing it and selling it unofficially, but they might even just officially be doing it. And of course, it might be popular. You might agree to that to make government taxes lower, but it would be nice to imagine that you actually know that's happening.
No, I checked the email.
Yeah, that's one technique, is to have different emails you keep track of. Yeah. I know there's a guy on Twitter, a security expert did this. He donated $1 to every political campaign with a different account to try to see what kind of spam they'll send. Man, I gave money to the Democrats, and they spam you forever. They send like 5 emails a day demanding money and text messages. It's really stupid. There's no way that's worth it. This is not the way to get money out of people. Just drive them nuts. And the political ads from Democrats on Twitter just make me disgusted. They're insulting, deceptive, dishonest. They're like malware ads. Whoever they hired for the advertising company is beyond stupid. Anyway, I'm sure they're losing votes with those ads. They make you want to go vote for Trump. And I saw the financial analysis of Elizabeth Warren's medical plan, and that will also make you want to go vote for Trump. Holy cow. She's managed to be stupider than Trump, which I didn't think was possible. But there's never a bottom to how dumb you can get. Anyway, hopefully we'll have somebody else like me or Pete or somebody it's okay to vote for. She is, and she used to work in economics, but her plan is insane. It costs too much money, and she doesn't know how to pay for it. You know, so hopefully we'll have somebody that isn't a lunatic to vote for. What's that? Well, yeah, but she wants to tax the rich, and still won't pay for it. Not even within a factor of 3. It's madness. So, you know, but there's still a lot of time for somebody else to come up that might be less crazy. Anyway, so which item contains the normal modified timestamp you see in a property sheet? If you just do the properties and file, you see a timestamp. Where did that come from? Okay, that's standard information, where you might imagine. That's where the normal time that you normally use is. All right. So what replaced the FAT table, which was the file allocation table in the original FAT disks? Okay, that's MFT. The master file table is the upgrade from the file allocation table. All right. Which timestamp is no longer used on Windows? MACE. What? I think it's E. I think this is wrong. Let me go back to the slides. I'm pretty sure it's E. I can't change the way that Kahoot is graded, but I certainly don't want to let it be.
Are you talking about the other ones, right?
I think E is the one that's no longer used. Yep. No, the access. Oh, it is access. Well, I'm wrong. Oh, well, that's okay. My Kahoot is correct, but if they would have asked me, I would have nuked this one. This one's actually useful. The last time it's read, they don't update that anymore. That's pretty rude. By the way, I used to teach Microsoft Office like 20 years ago, and my students would cheat on the homework, and I would totally catch them. Because inside Microsoft Office, they have records of the changes that made in a file and when it was originally created. So I could totally say you took another student's file and changed the name, and I can totally see it right here. Now, what's funny is I told them, they would come and lie to me and say, you're not cheating. And I say, dude, I worked with Microsoft Office in a business, a financial business. I have evidence that would hold up in court. I know you're cheating. They would say, how did you do it? And I say, if you still want to know when the course is over, I'll tell you. And they never came back. But the fact is, Microsoft Office puts another layer of metadata, which has gotten a lot of people in trouble. Another thing about Microsoft Office is if you make changes, the old data before and after the changes in there, there's a bunch of famous cases a few years ago where people would send like a contract to someone and you could go and see, oh, they were going to offer more money, and then they loaded it to this number. Those extra metadata is in there. And so there's special tools just to take the data out of your Microsoft Office files before you email.
This is the first time I'm hearing.
Yeah, what's that?
First time I'm hearing this, like metadata in Microsoft Office.
Well, yeah. Oh, well, it's been around. No, another thing is PDF files. If you redact PDF files, what a lot of people do is they just draw black stripes on them, and the data is still underneath that. And you can just open it in the PDF editor and take away the black thing and see the hidden data underneath. That happens a lot to like classified documents and redacted court records and stuff. They don't redact it properly. So anyway, this is actually there were a whole bunch of scandals caused by that. In fact, one of the San Francisco district attorneys came to take my class because they made that mistake. They published records that weren't properly sanitized and leaked out data that shouldn't have been leaked out. So they came and took one of my forensic classes to learn more about this stuff. Anyway, so I started the lawsuit. I might as well tell you, I started a lawsuit over this issue. They sent me a list of people to mail something to, and they did not remove the ones they didn't want to mail to. They just right-clicked on them in Excel and he hid them. So you wouldn't see them anymore. So if you printed it out, they wouldn't be in the printout. But when I ran a mail merge, it got every name and address, including the hidden ones. And I had in the court order, they said, we promise we're going to tell all the staff that they're suing their boss, but we won't tell the managers. And I sent this letter to all the managers by mistake, and it started another whole lawsuit. And when I told this story, when I started teaching here, the lawyer that started that lawsuit was in my class. It's a small world. Anyway, so anyway, that's the game. That was imperfect redactions. Anyway, so, oh, there's more eye clickers. That's where you are, pardon me. I've gotten distracted by thinking the eye clickers are wrong, but they were not wrong. They've turned off the access timestamp, which is rude. Anyway, all right. So which one is not visible inside Windows? That's the entry modifier. And by the way, that's useful then because tools you run in Windows can't fix it, and so it might be left in its original state. All right. Anyway, so let me get my this thing up. All right. All right. And so I got, this is CNIT 152, oops, November 7. Okay, and so it's 3 for WK and 3 for Anton. Whoops. Okay, okay. All right, good. And that should be a 3. All right, good. So, so we save this. Okay. Okay, so another project I used to have, which I mentioned last time, I decided to cut out of class because it was kind of painful. You can fix broken data runs. This is what your forensic tools do. And this is what tools like PhotoRec do. They can take like a SD card with the damaged clusters and they can reconstruct the pictures on it to some extent. So you can take somewhat broken data and try to fix it. So these are data runs. So if you look, the master file table can store small things like up to 700 or 800 bytes. So they'll just be stored right there in the master file table. And those are called resident files. Those files live entirely in the master file table and they do not live out on the disk in the clusters. but most larger files live out in the clusters. And so the master file table may actually have leftovers from these resident files. You might find bits of them left over in another master file table entry, might have some data left over from before. This is one part of file slack. File slack is little pieces of files that are left when other files have not completely overwritten them. And there's also alternate data streams we talked about before. This is actually a Microsoft feature that they added for compatibility with Apple, because Apple started to get big in music before Microsoft did. And in music, you want to have the sound itself and the album art and the liner notes all tied to the same file name. So there are multiple streams of data tied to the same file name. So a file name is actually like a drive name that can contain other files inside it. And that's what alternate data streams do. They all share the same timestamps, though. There's only one metadata entry for all that. All right, and so I mentioned this Slack space. All right, so you can see alternate data streams here. You can put hello world in out, and then you can put data in out.txt : secret.txt. You can treat the file name like a drive and put a colon on it and put more files inside it. And those are the alternate data streams. This is not commonly done, but it is possible on Windows operating system. And there was a time about 10 years ago when malware could hide stuff in there and virus scanners wouldn't look in there and you wouldn't get caught. Now everybody's onto it. Anyway, so another thing that's used is the zone identifier. If you download a Windows, especially modern versions of Windows, like Windows 10 and Server 2016, if you download a file and you try to run it, it will often not run. You have to right-click on it and go to Properties and unblock it, because there's metadata in the file that says this file was downloaded from the internet. And it won't treat it the same as a file that was copied from a USB stick. It considers it less trustworthy, so that's the zone identifier. And so you have a security policy that will treat files that are downloaded from the internet differently than other files. I know this is true of the Mac too. My Mac always, every time I download something and run it, it says, wait, this file came from the internet. Are you sure you want to launch it? And Microsoft can do that too. All right, so here's the point. I downloaded iTunes, and if you go down here and look in downloads, if you do a dir/r, it's the switch to show these other files, and you can see that the thing I downloaded, iTunes Setup, has iTunes Setup : zone identifier data. So there's a second data stream attached to things that came from the internet just to mark that it came from the internet. So alternate data streams are now used as a security mark.
Can you modify those?
Yes, I don't think they're protected by, they're not cryptographically protected or anything. You can delete them and modify them. And it's not just like you can just right click, go to Properties and unblock it. And I think that does just delete it or modify it. So I mean, yeah, it's not particularly strong. It's no more than like the read-only bit. You can right click on Properties and turn on the read-only bit too, which means. Yes, yeah. I mean, so it's not like a very strong security boundary. It's just, the idea is to prevent web pages from downloading stuff and executing it without you knowing it. Because there's a series of vulnerabilities in browsers that did that. They call them drive-by downloads. You open the page, it downloads something and runs without you even doing anything. And that's what this will prevent. All right, so you can analyze the master file table. This is why I really don't do it by hand very much anymore. We used to have some projects where people would actually patch broken data runs, but it's not worth it. There's a bunch of tools that will do it. SleuthKit is the open source tool that will do this. SleuthKit is the open source imitation of NCase and FTK. And it can do stuff. It's not as good as the professional tools, but of course it's free and it can do a lot of this. And there's a bunch of other tools that can analyze the master file table. Microsoft has index attributes too, because Microsoft has had a huge problem. In the days of Windows 2000 and Windows XP, there was this thing called Rover the Search Dog. You could click Start and go to Search, and then you could search for a file on your hard drive. It would take like 10 minutes and then not find it. And Google made this thing called Google Desktop or something, where you would install a Google app, and it would have a little bar in your Windows XP desktop, and you could just type the name of a file, and by the time you typed the third letter, it found it. It didn't even have an enter button. It didn't even take 1 second to find a file, and they humiliated the hell out of Microsoft. And when Windows 98 came out, Bill Gates said, we are going to make a better search engine than Google within 6 months, and the world is still laughing. They finally came out with Bing, but Microsoft does not know how to make search. And they tried over and over again to put some kind of index on the disk to make searches faster, and it always failed over and over and over. They've been doing it for 20 years. Microsoft cannot index something. They can't figure out how to do what Google does. Google, of course, that is their whole thing. They can index the whole internet, so they can totally index your disk and find stuff really fast. And Microsoft is still a mile behind on it. But the index attributes are there in Microsoft's many aborted attempts to somehow make some kind of index so searches will be faster on the disk. Anyway, so Redline is a Mandia tool that has an opportunity to parse index data and look in there and get information about what's on the file from that. All right, I got some cahoots about that. This is 11, no, this is 12A2. All right, good. But you know, what Microsoft is good at is business, like Microsoft Office. What Google is good at is like logic and math and databases, searching stuff. Everybody has their log sheet. Facebook is good at understanding what people like at like parties and like dating. That's their thing. They understand that part of life. Every company has one strength. And they all try to do the thing they're no good at. Like Google keeps trying to make a social network and they just create disasters every time they do it. Because they're like the board. They do not understand human society. And they try to create a database that will simulate human society and it doesn't work. And of course, now Facebook is hitting the wall. They do not understand what Congress demands of an American business. They think they can do anything they want and Congress will put up with it. And they're finding out that's not really true. Anyway. Yeah, pay taxes. Yeah, that's the strongest argument against the Democrats. You know, I really hate Trump, but the right wingers say that the Democrats are going to raise our taxes, and unfortunately, they're right about that. Anyway, it's always the lesser of two evils. I don't think I've ever voted for anybody I actually liked. I just voted against other people. Anyway, that's life. So which one of these is 1 kilobyte? Yeah, the MFT entries are 1 kilobyte. The FAT was like 32 bytes. The 8.3 file name and just a couple other things. That's why they have now a whole kilobyte of data to store about every file. Enough room to store the access control list and all these other things.
How big is that? I guess.
It's about a megabyte.
Okay.
MFT is not that big.
Huh.
Yeah.
Right.
In fact, this one looks like 64K there, but it doesn't have to be that big. Yeah. I know. I don't think it uses all that data all the time. So anyway, so which one gives you the clusters that have the file content? Where is that? There has to be a list of these things. Yeah, that's the data section. Those are the data runs. The clusters are 4 kilobyte chunks of data. You can't allocate less than 4 kilobytes, and you have a group of them. And normally, they're just in a row, 10, 11, 12, 13, 14. But then so you delete files and add more files, and it tries to put a long file, and there's not enough room in one place. So you get fragmentation, where part of it's here, and then part of it's here, and part of it's here. And that's listed in the data section, the clusters in order. Yeah.
The data section itself is part of MFT?
No, it's a separate file.
Separate file.
Yeah, separate file, but of course, it's tied to the MFT. So the MFT has the file name and the access control list and the creation dates and stuff, and then a link to the data section, which has this long list of data clusters.
Okay.
Yeah, because that could get long. And that's called a data run. What's that?
And that's how the MFT stays small.
Right, I think that's right. The MFT is just metadata, and some of it's outsourced. And that's where these files are connected to each other. Yeah. Yep. And so which one contains timestamps for deleted files? Okay. Yeah, the index may still have entries of old files. And as we're going to see, the prefetch folder has entries for deleted files. When you delete a file, this is the fundamental problem. This is why people get tools like Evidence Eliminator. If you delete a file, that doesn't mean there's no tracks left of what you did. If you want to do something and then lie about it on Windows, you're pretty much hosed. Windows is like having a video camera recording everything you do. Even reformatting and reinstalling the whole OS does not clean it off. You need a professional forensic erase to really know that that data is gone. It's taking many records of everything you do. It's like the internet. If you go on the internet, everybody's keeping track of everything you do. Your ISP, all the advertisers, all the cookies, you know, the whole world is watching everything you do on the internet. There's no real hope of hiding it. Anyway, so where are small files stored? That is, okay, you can say they're in the MFT Slack. I think resident data might be better. But anyway, it's stored in the MFT. I think resident data is a better answer. But anyway.
Resident data is in Slack.
Well, but I guess, but I don't think I'd call it Slack unless it's left over from a previous file. So, you know, I wrote these a couple of years ago and I'm not thinking the same way now. Anyway, that's why this stuff is extra credit. There are some defects in the cahoots. Here, so K is probably Carla. Joe is probably Joe. And WK is a two-time winner. Good. All right. So anyway, let's take a look at the last section here. All right. And so there, the log file keeps track of things. This is a problem. This is one of the huge advances of NTFS. FAT did not have a log file at all. So if you were using the computer and saving a file on a disk, and then you had a blue screen of death, it would crash. And when it booted up again, it would find all this data on the disk and have no idea what it was. It would find data sitting there, not yet tied to a directory entry, and it would call it lost clusters. It would make you wait 15 minutes while it said finding lost clusters, and then it would put them on the root of the drive called file000.txt, file001.txt, because it didn't know what they were. And to fix that, they switched to a journaling file system with NTFS, so it keeps track of what it's doing. It says, I'm opening a file, I'm reading block 1, I'm reading block 2, I'm writing block 1, I'm writing block 2, poof, blue screen of death. So when I wake up, I look at the journal and find out what I was doing. Now I know what this stuff is, and I can finish the task that was in progress. That's much better. Anyway, that's what the journal does. It also has weird consequences. When I taught a class in Windows XP and another teacher taught a class in Server 2003, I updated the XP partition in a shared machine to Vista, and that killed the Windows 2003 separate partition on the machine because the Vista updated the journal version. And when the journal version would now be updated on every partition that Windows saw during boot up. And the installed 2003 could not boot with the new version. So just touching the volume to have it appear in my computer with a drive letter changed it. And that was my introduction to this world. In the modern computers, they write data to every volume they touch during boot up. So you really need a hardware write blocker if you want to boot up a drive at all to read what's on it. Just before you see the desktop, before you log in, it has already written to everything it touches. Unless you have a special forensic operating system, it doesn't do that. It updates timestamps, it updates journal entries and stuff, just saying I've touched that volume. So you don't have a pristine evidence volume that's not being altered unless you have a hardware write blocker in there. Or you have a special operating system that doesn't do this. Anyway, so that's the game here. It's got information in a log file. It's got a USN journal, which is another journal. And you have shadow copies. This is something that came out with Windows 2003 Server, and it was a big hit, and Microsoft expanded it greatly in every later version. The thing that came out actually in Windows ME was restore points, where it takes the critical system files and makes a backup copy, and you can restore to a previous time. And this increased to shadow copies, so it's keeping old versions of files. So you can, now if you delete a file, a shadow copy doesn't help you because there's no way to go back. But if you modify a file, you can right click, go into properties, and there will be shadow copies of the old version of that file. This is because Microsoft found like 90% of all restoration backup are just to get to an earlier version of the same file. And they decided to just have an automatic system that always makes it right there. But this means if you delete things, there is stuff in the shadow copies. And modern operating systems do have shadow copies of almost everything, including your desktop and documents and everything. So there are tools like VSS admin and make link commands. There's automatic backups out there so you can find shadow copy sets, and forensic tools will actually let you explore the shadow copies and see the old versions of files. Yeah?
Is this a lot of work? I've always wondered if it stores shadow copies. Well, just how much stores shadow copies? If it journals changes or if it's actually storing full backups of
Well, this is actually a very good question, because you will find that this is not previous system restore is not available on servers. And the reason is it changes the contents of files, but it does not back up the metadata. So the permissions and stuff don't go back. So what happens is, if you have a Windows desktop machine and you use system restore, every time you do it, you damage the system. It's not really the same as like an image backup, which would be 100% back. It only stores the contents, not the metadata. And that means, that's why they never put it on servers, because they found on servers, it does enough damage that you wreck your server. You don't want people using, you just want people to get used to really backing up their server. You don't want to give them this lame halfway thing and pretend it's good enough, because it really isn't. But these copies are just the data, not the metadata. That's my understanding. So it's not a real image backup is much better, of course. Then you go back to 100% the way it used to be. Although, to be fair, even that is not 100% back, because images don't want to waste space. So if you have a 500 gig drive and you're only using 100 gigs, your image backup will only be of the 100 gigs in use. And the restore will only restore the 100 gigs. The other part is not erased. It is possible to make a complete image of the whole drive with a forensic tool and restore it with a forensic tool and wipe out every block, but that's not what's normally done, because you don't normally want that. And also, to be fair, if the drive is bigger than 500 gigs, bigger than 1 terabyte, it is impossible to ever erase or restore the entire drive ever, because the controller has extra blocks they don't tell you about that are silently swapped in for bad blocks. So when you think you've written every block on the disk, you haven't. There are hidden blocks you can't reach unless you hack the firmware. Anyway, but that is not general knowledge. That was a private communication from Travis Goodspeed, and I told him you got to write it up, but he never bothered writing it up. So I'm not sure very many people know that, but he wrote it, he hacked the firmware, and he said he was able to recover 50 megabytes of good data from a forensically erased 1 terabyte volume. So, this is why business people have learned, when you're donating computers, you just grind up the drive in a chipper. Don't trust any erase procedure. You can't trust any, just physically destroy the drive. Then nobody got that data. Otherwise, these erase procedures, you can't trust them. Anyway. That's right. Even a forensic image is not everything. And certainly a normal backup image is not attempting to get everything. It's only trying to get the active files. You don't want to waste time copying the unused part of the disk. Who cares? But even a forensic image is not perfect. And it doesn't have to be. There's another area. There's the administrative area of the disk, which is used for the firmware, which we talked about before, the host protected area. And there was only one forensic tool that got that, and it went broke because nobody cared. You don't actually need 100% of the disk, right? I mean, when you catch a crook, you don't get every piece of evidence in the world. You just get enough evidence to get a conviction. If they killed 10 people, you prove that they killed 5 of them and call it a day. And you don't need 100% of the evidence on the disk in practice. You just need to get like 99% or something. That would be enough probably. Anyway, you can list shadow copies with VSSadmin. There are command line tools to list the shadow copies on a disk and to remove data from them. And forensic tools will just show you a volume you can just open and go through a folder structure like NCase and such. So their shadow copies are a mirror of the entire file system at the time, and there are a bunch of tools that will explore it for you, like Shadow Explorer and stuff. And the big expensive forensic tools like NCase and FTK have got this all built in. So you can totally explore the shadow copies available. Now, here's another fun thing. There's a file system redirector, which you've seen. If you launch a program, if you run 32-bit code on a 64-bit Windows, then it actually runs it in this little virtual machine-like thing called WoW 64, Windows on Windows. And it actually has a separate place. And so when you are in a 32-bit program and it tries to write to the registry, for example, or to a critical system file, it doesn't really write there. It writes to this other place where it thinks it's writing to the registry, but it's only writing to the virtual registry, which is only visible inside WoW. This is what has to happen because your old code that believes it's on 32-bit Windows XP has to see a Windows XP registry and be able to modify the Windows XP registry, but you can't let it modify the real registry. It would break the modern 64-bit programs, so it lies, just like a little bit like a virtual machine, and that's called a file system redirector. And what this means is if you install a 32-bit utility like an antivirus or a forensic utility, it might not see the whole system because all 32-bit code is actually running in a sort of limited virtual environment on your 64-bit operating system. It doesn't really see the whole drive. It thinks it does, but sometimes when it tries to go in folders, the operating system redirects it and lies to it. So that is a thing to be aware of. Yeah.
So what's the difference between 64 and 32?
The 64-bit system, the simplest thing is it's more addresses at a time and it's faster. But in fact, Microsoft changed the way things work. They changed the structure of the registry, they changed the permissions, they added new features, and the old 32-bit programs don't know about that. For example, if you go back to MS-DOS, there was no programs file, and there was no users file. Every programmer just makes C Quicken, C Lotus. It puts stuff right in the root of C. That's how everybody did everything. And Microsoft finally decided this is for the birds, so they made C users Sam, C users Joe, and then they made your profile. Your desktop is in the C users Joe, and my desktop in the C users Sam, and stuff like that. That's the modern way. But if you run old software, it looks for the old structure, and it simulates that structure. And when Windows Vista came out, and Windows 7, people were very, very worried that their Windows XP software wouldn't run. And Microsoft put enormous effort into making this work. So your old Windows XP software will see just what it expects to see. For example, in Windows XP, it was C Documents and Settings username. And Windows Vista, it was C Users username to get to your profile. And all the Windows XP software tried to go into C Documents and Settings, so they made a thing called a junction, a special pointer to Documents and Settings inside Windows 7 and Vista, which made it so you could use the Documents and Settings name and you would go where you needed to go without ever knowing that. A little bit like virtual machines. So that's an issue. Yeah.
So with file system redirectors, it's not that 30-bit, 32-bit programs can't read a whole sector of the file system. It's that they just get redirected from one.
No. If they try to read certain folders, they get lied to.
Right.
There are folders they cannot reach. They can only reach the simulated folder for 32-bit OSs. It's a little bit like they were virtual machines. Right. That's the idea.
Could you, but does that, sorry, that doesn't mean though that if you have a 32-bit antivirus, it won't be able to look at.
No, I think it does mean exactly that. If you have a 32-bit antivirus, there will be folders it can't scan that it will never know about. And by the way, there's a rootkit called the Blue Pill, which Joanna Ryszkowska wrote, that does this to your whole computer. It moves your whole computer into a virtual machine, and now all your software does not know something else is happening. It's bloody awesome. She makes the greatest rootkits in the world outside the military. She gives very good talks. So, all right. So, and then there's Windows Prefetch, which you'll be using in the lab. This is a nice, simple, easy one. When Microsoft brought out Windows XP, computers used to have like half a gig of RAM or a quarter of a gig of RAM. And some of the machines had like 2 gigs of RAM. And in fact, they only needed like 1/4 of 1 gig. So it would just sit there unused. So everybody freaked out when they went into Task Manager and Windows XP came out and they saw all 2 gigs are being used. And they said, this thing is a hog. I mean, I ran my Windows 2000 on 64 megs of RAM. I upgraded to Windows XP with 2 gigs and it's using 2 gigs of RAM. What is this crap? Well, what's going on is Microsoft knows you paid for that RAM and they don't want you to waste your time. So what it does is you're only using maybe 128 megs of RAM, but the rest of the 2 gigs is being used by this process to get things ready in case you want them. So it keeps a log of all the programs you've used recently. And while you're not doing anything else, it loads them in RAM before you launch them. So they're ready in case you want them. So that's what prefetch is. It fills the prefetch folder, and the prefetch is when nothing else is happening, I'll just load stuff in the prefetch folder in RAM because you're probably going to launch that because you launched that recently. And the whole operating system customizes to try to make whatever you do more often happen faster. And that's why there are all these records of everything you do being kept. So that's the game here. There's a boot prefetch, and then there's layout, then there's these application names, and then a folder. And we'll do this in the lab. So
does this also apply to Windows, Microsoft, Apple?
Yeah. Well, I don't know about Apple. Apple, I'm not sure Apple does this, but Apple does a lot of the same things. It also is custom, remembers where the folders are, remembers what you've been doing for performance reasons.
Yes, they have this new operation system, the 10.14 or 15. You need some steel thing, but there's a new operation that
you mean Apple's new OS? Yeah, I know they changed a lot of things. I know Apple does a lot of things. Like one thing they did, which Microsoft was real slow to catch on, was they compressed the RAM. they zip files in RAM to fit more stuff in RAM, which is pretty brilliant. Microsoft does this horrible thing called paging, where if the RAM is full, it starts copying data to the hard drive to make RAM empty. What Apple will do is just zip the files in RAM to make more room, which is much faster, like 1,000 times faster. So it really makes a difference. But what it means is if you try to do what we did, RAM forensics in an earlier project, you'd copy the RAM from a process. If you do that on Apple, it doesn't work. The RAM is zipped. So you can't read the strings in it. You need a special tool that costs hundreds of dollars to do it. That's why Apple forensic tools, the free ones are all garbage because they're like 6 versions back, and Apple keeps adding advanced features. You have to pay money for like Black Bag. Black Bag is the premier Apple forensic tool, and it costs thousands of dollars, and you have to pay for it if you really want to image Apple machines.
Do many Linux distros compress RAM?
No, I haven't heard any Linux distros doing it yet. It was Apple, but I think Microsoft is starting to do it because this is why a project in the 127 class stopped. I used to have a heap spray project. You used to be able to run a JavaScript that put a copy of your exploit in RAM and make like 10,000 copies of it to fill all the RAM, and it was all just sitting there. And if you do that in a modern version of Windows, it doesn't work because the strings are no longer stored literally. They're like zipped or encrypted or something. And I think they did that just to stop that attack. But anyway, so you've got, so this prefetch folder launches, it keeps track of the last 128 programs you've launched. And according to a paper I read today, in modern version of Windows, it's now up to 1,000 programs. So all the last 1,000 programs you launched are recorded there. And even if you deleted that program, the record is still there for a long time until you launch 1,000 new programs after it. So there's a record here of what you did in the past, because under certain conditions, the machine will decide, I've got nothing better to do. I'll just load this program in case you want to use it again. That's all it's there for. So you can see it. There was a tool called Win Prefetch View. I found a different program I put in the project here. It'll show you. You just see everything's been launched and when it was launched. I'll show you the modern tool. I wrote this project today that works on Windows Server, which is awesome. I haven't had this in this class for several years because it was only available on client versions of Windows, not server versions. But I finally found a good blog telling me how to turn it on server versions so we can do it. For years, I've been unable to do this. Anyway, so event logs are also there. Microsoft has a bunch of event logs to record what it does, and you can turn on auditing and have more event logs, but it keeps track of a lot of things by itself, like successful, failed logon attempts, creation and start of system services and such, and all the applications choose to log things like antivirus logs things. If you try to print something and the printer's out of paper, it logs that. If you go to DHCP and get an IP address, it logs that. It makes thousands of events per second. It's recording a lot, even when you don't turn on any optional log. So there's the application log, which is information about the installed applications. There's the system log, which is, of course, internal operating system processes like DHCP and DNS and such. And then security logs, which is internal processes that have security implications like log on and log off, changing user account control, turning off the firewall, things like that. They all go in the security log. Yeah.
Does Linux do something similar to
Yes,
this?
Linux has a syslog, and it keeps track of very much the same kind of stuff.
And that's not wipeable or.
It's totally wipeable in both cases. In both cases, it's just a normal file, and you can just delete that file. You can open the file and modify it. And that's why if you try to take these logs to court, you've got a problem, because they're nothing more than basically like a notepad file. And you say, wait a minute, I could have just changed that entry and put in the wrong stuff. And you say, yeah, you totally could. If you want a log that you can trust in court, you have to get a third-party professional logging utility that actually signs and encrypts it, so it can't be altered. You can do that, but the default log is not intended to make an unerasable record. It's just intended to help tech support people fix the machine. So it also doesn't keep much time. It throws away the log after a while, like 7 or 30 days. It's just there so you can find out what's wrong when your machine is not working.
Back to the Windows part, for the last 1,000 programs of Linux
Prefetch.
does the same thing too?
I don't think it does. I think this prefetch thing is a weird idea Microsoft thought of, and I don't think anybody else bothered with it. It was just this idea to have that stuff waiting for you in RAM, and I think sort of like garbage collection on SSDs, I don't think it really helped that much. A lot of people would turn it off on desktop machines and say it's a waste of time. I don't think it makes a huge difference. Microsoft has quite a few of these performance improvements that in retrospect turned out not to be a brilliant idea. but it is still available. So I guess they think it does some good. Anyway, so you can find logs all over the place. Here's where they're stored in a registry key, and you'll find them in these XML files on Vista and later Win event logs in EVTX files, because Microsoft switched to using XML for almost everything. They used to use proprietary binary formats for everything, and they pretty much reformed around the time of Windows Vista and switched to using XML for everything, which is much better. And the main reason for that is because of lawsuits. You get a lawsuit, and they sue your company, and now your company has to find all the documents about a certain project for the last 7 years. And you really wish everything was just in plain text, so you can look for a keyword, and it was not in 100 different screwy binary formats, which is the way Windows was. Anyway, so you got these EVTX files, and you've got logs for Task Scheduler and the firewall and user access control and all these things that are running. Terminal services, App Locker is Microsoft's security boundary, which is App Armor on Linux. This is where you have limitations of which application you can launch. Anyway, then there's everything in the log has an event ID. This is the main thing you work from in Microsoft Windows world. Your event ID, you can Google the event ID, and they'll find out what to do. And by the way, Microsoft has help pages about event IDs and are always completely worthless. Microsoft is useless, but there are independent forums where system administrators post, like eventid.net. You can totally find out what it means and what to do about it. So I used to teach desktop support for years, and this is a project to give my students. Just take one error. Every Microsoft Windows machine has thousands of errors. Take one error and follow it all the way to the end until you find out what happened. And you can take each one of these, and you can spend hours of research finding out why does this machine have this error and what do you have to do to fix it. Anyway, so here's log on events 540. And if you did the forensic, the Splunk task, we were looking through these Windows event IDs, trying to find out who plugged in a USB stick and when did this person log in and what was their IP address. You're looking at these raw events. So there's different types of login. Interactive is at the keyboard, over the network, and services and so on. There's different kinds of logins stored with different information. Yeah.
These tracking security event?
Yes. You have security events. This is login event ID 540. Yeah. And each event has data attached to it in addition to the event ID. So a lot of information. That's why this is what you're mostly looking at if you look at Splunk. You're looking at the logs created by the Windows operating system and other devices. And they really log a lot of stuff by default. The problem is, it's hard to look through all these logs, and that's why SIEM was invented, to have an easy way to look through all these logs. So you've got information about what was logged, and as you do see, if you do Splunk, it even stores like MD5 and SHA-1 hashes of the processes, so you can tell if a process has been modified when it launches. They really give you a lot of information. So, and, of course, as you know, attackers will hack in by getting somebody to click on an email attachment or something, and then they get that login, and then they steal other hashes and move to another machine, and they're stealing accounts and moving back and forth as you go ahead, trying to get to the domain administrator. And so they'll go into Windows 7, they get malware on it, so that's joined to a corporate domain. So now they get the domain login for that person and use password dumping. Now they have the local administrator, and they find a domain administrator because the domain administrator is running some process on the local machine, which is unfortunately very common. Ever since Windows Server 2000, Microsoft has always said you have to not use the domain administrator account on workstations, but everybody does because it's too much bother. Until in Windows 8 and Server 2012 R2, they provided an optional feature called siloed accounts. You can make a domain administrator account that cannot be used on the workstations, but it's not on by default. You have to set it up. But for 12 years, what's that?
Siloed accounts?
Yes.
That was as of 2008.
2012 R2 and Windows 8.1 is when it came out. So it's available now, but you have to set it up. And they say that's what, because they're tired. For 12 years, they told everyone, it was in the classes, I had to put it on the certification exams. Every administrator has to have 2 accounts, one for doing administrator tasks and another one for logging on the workstations. That's not the domain administrator. And every time you want to do something on the domain, you're supposed to right-click, run as, and type in your domain administrator password, so it authenticates that one action, but it does not store a local copy of that hash where it can get stolen. But nobody ever bothered, of course. And Microsoft finally made it possible to enforce that. I don't know if anybody really did, but it certainly is a good idea. That's because of the pass-to-hash attack. If I could steal the hash, I can use it to log in. And it's been a problem for 25 years on Windows. And this was their response. They cannot stop the idea that a stolen hash can be reused, but what they can do is stop leaving that hash all over the place where it's easy to steal. That's their defense.
But it can't be enforced on server 2008.
Right, on server 2008 or 2012, before the R2, there is no Microsoft provided way to do it. Now, people put on these third-party security things like LANDesk, and they add extra features. So it might do something for that. That's why a lot of people have security suites to try to add security features Microsoft has missing. I don't know, a Carbon Black or something might do something, I'm not sure. Anyway, so then they get a command shell, they mount a drive, and then they use PS exec to remotely execute things. So once you have an administrator password, you can launch process on another machine with PS exec. Then they can use remote desktop to move around in the network and go to the server and use NTLM authentication. You know, you hop from place to place, and you'll see all this in Splunk. They took over this machine, they hopped to this machine, they hopped to that machine. That's what you have. So see a lot of you login type 3 on this machine, type 3 on this one, another login type 10 over here, a login type 3 over here. All these authentication events from machine to machine are stored in the Windows event logs. So it's all there, and you can track it down with a system like Splunk if you know what you're doing. So if you try to change things, it'll go in the security settings. So if a user account is created or promoted to administrator or deleted, you'll see that. If they change policy settings, like they try to turn off audit logging, you'll see log events for that, and so on. You'll also see an event when they clear a log. So of course, you could probably clear that event too, but anyway, it is created. Anyway, and then you have process auditing, which you can turn on. It's not on by default, and then it logs every process, and this is even more detailed. You can also log every person that goes in a folder, everyone that opens a file. These things slow down the machines, but they give you a more complete trail for high targeted values. So the service system logs record every time a service starts and stops, which is very common. You often make automatically launching services to make malware to hit resistant. Anyway, I think we're about at the end here. Here's PS exec. Here's the logs it had. The event ID is 735 and 736 showed PS exec making it launching something somewhere. You know, there'll be logs kept of every process launched and every authentication event. So people using PS exec might be not permitted at your company anyway, and if it might be unusual usernames doing it, known bad service names, and so on. These are suspicious things. We talked about this before, like things that are launched and then deleted and never used again. Programs that have only been run once, that's pretty suspicious, that sort of thing. So you check for the antivirus. Of course, that would be awesome. If your antivirus or intrusion detection system would go off, that makes it easy to tell a bad thing is happening. You have to adjust the logs to be bigger to keep more history. And there is a tool to fix application logs if they get corrupt. Microsoft databases have always tended to corrupt easily, ever since Outlook Express. They're just buggy in their database, so they have special tools just to fix broken databases. So there's a lot of tools here. I think we're coming up to the last iClickers. It's taken too long and we're 20 minutes over. I think I'm just going to record this as far as we got. This Windows stuff gets kind of deadening. We'll look at more of it next time. I don't want to make you people, I don't want to continue because I don't think people will retain it. But I'll just point you to the project or two. That would be a little more likely to wake you up. There are 2 projects I just added today where you do a little bit of this Windows forensics. I used to teach classes basically entirely Windows forensics. And I moved away from it because, you know, I think you use tools that do a lot of it for you. But let me see if I can figure out a browser that works. Okay. But anyway, here's the new project is 307 and 308. And I think this is a lot of fun. These are both pretty easy and to not do for a couple of weeks. But 307, you do the prefetch folder. I used to not be able to do this on servers, but I finally found out how to turn it on. You do these 4 Windows PowerShell commands, and that turns it on. Uh-oh, this looks like the wrong kind of quote or something. I'll have to check that. But anyway, once you've done those 4 commands, now the prefetch folder will have data. If you always open the prefetch folder on a server 2016, it'll be empty. It's C Windows prefetch. And once you've turned it on, it just stores records of everything that's been launched here. And it automatically stores system things. But if I've launched WordPad, it will show up here as WordPad.exe, these PF or prefetch files. And they're not very big. They're just a few kilobytes each. So now I launch Bowne server, just this thing I use in other classes. And so now you can examine the prefetch files directly, but they're like a binary file and it's hard to read. So you run PE command, is a prefetch folder parser. You download this thing and run it, and then it makes a comma-separated value out of the prefetch file. It fills pages this and ends up with some purple messages, and now you have a comma-separated value, which you can open in Notepad or WordPad, but it's still miserable and hard to read. So you put on OpenOffice to get a spreadsheet. If you have Excel, that would be fine too. And now you can open the prefetch file, the parsed prefetch file, the CSV, and you will get a spreadsheet, which has one line per application. So here's Firefox getting launched, here's Notepad getting launched, and here's Bowne server getting launched. And there's a lot of columns here. You have the name of the thing that was launched, you have all the creation dates, then you have a list of all the DILs that it used, all the folders it opened, big long entries are over here on the right. And so to make it easier to read, you copy one line of this and then put it down in Notepad. This is all the data in one line. So you have the name of the program and then all the creation dates, and then you have a list of the user that launched it and all the folders it opened and all the files it opened. And every program, as you know from the other classes we've done here, like the malware analysis class, every program uses like a dozen DIL files, and they're all listed here. apphelp.dil and kernelbase.dil and sysmain. All these DIL files are part of launching that application. And one of them is one that came from the Bowne server directory itself, so that name is something you can choose for a flag. Anyway, you can get a clue how this works. And if you do the Splunk projects, you'll see how all this junk is in Splunk, and you have to get used to searching it. Anyway, that's the prefetch folder. And the other one is OS Query, which is the Linux version, although supposedly you can now put this on Windows too, and I haven't tried it. This is originally intended for the Mac and Linux. It's a Facebook product, and it's really pretty awesome. You install this OS Query thing, you just get a new repository and apt-get, you can put it on your Debian machine, and now it runs a local database of system monitoring tools. And you can look at them. There's tables for everything. Sources of software, authorized keys, CPU time, cron tab, which are scheduled tasks on Linux. You can examine all these things and logged in users, network connections, and everything else. And you can configure it to harvest the syslog. And then you can configure it to do file integrity monitoring, which I thought was pretty awesome. Took me a while to get it working, but you put in these files, and now you can specify folders for it to monitor. And that's what you have here. It's going to look at home and etc. and temp, and anything that changes there, it's going to tell you. So after you get it properly configured, now if you just go and monitor the log, you can open another window and touch temp AAAA. And when you create a file in the temp folder with that name, it will make an event telling you that file has been created. So it's monitoring and telling you if anything changes in the monitored folders. But this is the Linux equivalent of those things you saw in Windows. So it's good, clean fun. And that's very productive. I used to do this horrible thing called Tripwire in this class, where you install Tripwire and it tries to make reports, and it's really hard to set up, and the reports are really painful. This is a lot nicer. And I've heard this a lot at cons. They use this to kick malware off Macs by monitoring files. So there is Mac malware, but and you can spot it with this. Anyway, so those would be a couple of good projects to do where you can play with this stuff for a bit. Any questions about anything? So as I mentioned before, if you haven't already done 310, 311, and 320, you might suffer greatly. It's really hard. If you get fed up with those, just do some other projects to get extra credit, like the Splunk is the best, or on my homepage, the Go. Those are much easier ways to get extra credit if you find it too difficult to do these. But if you plan to really work at a corporation, then you really got to get used to the madness of Windows servers. And then you should get good at making domain controllers and installing enterprise class tools. But if you've never done it before, it's a lot of work. There are a lot of bugs. The instructions never work. You always have to stop and take error messages and Google them and solve irritating problems to get anything to work. And it never gets any better. Enterprise stuff is just big and complicated. Anyway, so I guess I'll stop the share. I see a chat message coming in. Multiple pass zeroing the disk. Oh, you only need one pass. If you zero the disk, it's gone, gone, gone. This multiple pass thing is a myth from 25 years ago, from a very old generation of hardware. Every one pass is enough. Multiple passes don't do any harm. They just waste time. One pass of 0 is enough to completely erase the disk. The only problem is there are sectors you can't reach, and no amount of passes will reach them. Yeah?
So don't SSDs have a certain number of writes you can make, and then you do the whole disk?
Yes, especially the old SSDs had a problem, but that actually, modern SSDs automatically erase all the time you're using them because of that problem. They optimize when to erase, and they move things around to get big blocks of data. The real problem with SSDs is you can't erase just one sector. You have to erase a whole big block, which is really big, like 4 megabytes. You can't erase one part. So the erase is slow because it has to erase a lot. So if it had to erase before, and you do have to erase before you can write a new file on. So if they didn't collect the garbage in the background, when you went to save a file, you'd have to wait for a long, slow erase process to make room for it. That's why they have background garbage collection that automatically erases unused stuff while nothing else is happening. So that when you go to save a file, there will be an erased block ready to put it in. And they're actually shuttling things around to defrag the SSD to make a block empty, so it's time to erase it. It's really doing a lot of stuff in the background. But it can only do that if you have a modern operating system and a modern driver, because in order for this to work, it has to know whether a file is still being used by the operating system. And magnetic hard drives do not know that. They don't know the difference between files in use and erased files. They're stupid. The operating system knows, but the disk is just a repository of data. It's got a cluster, and it doesn't know whether that has been deleted yet or not. But SSDs do know if they have the most modern OS at the other end and the most modern driver. Anyway, good. These are good questions. I guess.
Solution is multiple paths.
Multiple paths is just a myth. A lot of people have this DoD erase. If you get Derek's Boot and News, you can just have 14 or 17 passes of random numbers. And of course, that's fine, but it's totally unnecessary. One pass of 0 will do all you can really do, but all you can really do is not enough, and you should just physically grind up the disk. That's the real message. There is nothing you can do that will really get it all. Anyway. Yeah.
There's always bound to be some kind of data left behind.
There are. And if you ever find some tool and you think you got it all, it probably means there was a subtlety you didn't think of. That's why people don't know this stuff from Travis Goodspeed. I'm telling you, never published it anywhere. They don't know how much data there is on terabyte drives. But I think the proper experienced people in the business know. Another thing I've been told, there are drives that come with a firmware erase command that will erase it forensically inside the drive. And people at data recovery companies have told me those things often fail, and the customer has no way to know that. You issue the firmware 0 command, the drive appears empty, you have no way to read it and verify that, and often it didn't. That's why, the only thing is a real test. There was a forensic company that bought a bunch of used laptops on eBay, and they found all this personal data on them all. They weren't erased. And then they bought a bunch of iPhones, and there was no data on them. iPhones do it right. iPhones, there's a way to do forensic erasure, by the way. We reuse the hardware, which is the way iPhones do it. You have to encrypted from the very start before you ever use it at all. Encryption is turned on. So everything you ever wrote on there was encrypted. And then when you reset it, you delete the key. That works. That means all that data, even the leftover chunks, even the chunks in bad sectors, is all gone because the key is gone. That's what iPhones do, and it works. But you can't have something you're using and turn on encryption later because some unencrypted data is already written on there. That's the only procedure that's safe.
For example, if you got if you can activate BitLocker
That's
with
right.
your TPM,
Yeah.
turn it on before installing the OS.
Well, you have to do it when you install OS. But I mean, if you before your user starts using it, typing anything personally, if you turn on BitLocker when you first configure the laptop, then I think it would amount to the same thing. That everything they do will be being encrypted. At least I'd like to think so. I wonder if I think that's probably true. But I do know there was a time when not everything was completely included. Yeah, go ahead.
I was going to say, but you're also, it's a double-edged sword. If you encrypt your hard drive, then fixing your computer can be a lot harder.
Right.
To get your I don't recommend actually encrypting your hard drive unless you really need it.
Yes, it does mean, of course, you can't run a repair utility and fix it. If it won't boot up, you're toast. So if you're going to do this, you better have a good backup system too. And then you got to encrypt those backups somehow. It's nothing ever. If you're just a home user and you're not backing up your stuff, then encrypting your hard drive is a pretty risky thing to do. It's a big issue. That's why everybody puts it in iCloud, and now it's totally available to Apple. They have the key. That's why, you know, the people with these totally secure iPhones, they back it all up to iCloud, which is totally under Apple's control. So, you know, but it has to be that way because they have to be able to read it even if you lose your phone. So there's just there's opposing considerations here.
Like Kate Lynn just said, double-edged sword.
That's right. You either make it easier to repair your machine, or you better have a backup somewhere, and that backup has to be accessible without the key on your machine. So, you know, you gotta make threat modeling and decide what's right for your application. There's no simple answer. Hey, okay, I'm gonna stop the share, and I'll stick around if anybody wants to work here. Maybe I'll go over and see the robots.
So we test